Hello, and welcome to Net 202. This is Scaling Applications with AWS Global Accelerator and Amazon CloudFront. I'm James Devine. I'm a Senior Specialist Solutions Architect covering networking, Outposts, VMware, and Snowstar. To get started today, we'll talk a little bit about the scale of AWS and how you can use that to help your applications. Then we'll get into talking about the two products that we have in this space, Amazon CloudFront and AWS Global Accelerator. And then we'll finish up with some getting started and how you can kind of get going with this today. To start talking about AWS's global scale, I think one of the unique things about what AWS brings to the table is our global infrastructure. So we have redundant 100 gigabit networking connectivity that circles the globe, both over land and underseas. It's all private capacity that's connecting our regions, except of course for China. But outside of there, we have dedicated private fiber running, and we encrypt everywhere we can. So you have a secure global network that you have access to. And that secure global network has 216 points of presence, which is where CloudFront and Global Accelerator operate out of. And that connects together 22 geographic regions that we have around the world that compose 76 availability zones. So it brings our users to that global capacity that we have in our regions. We also plan to globally expand. We're dedicated to continuing to grow and expand our network. We have 9 more availability zones and 3 more regions planned in Indonesia, Japan, and Spain. So why does having this global background help you as a customer? First and foremost is security. We say security is job zero at AWS. We're always concerned and take security very seriously. Any traffic that traverses our infrastructure rather than the internet. So it stays local to our network. It's not going out over unpredictable paths through areas we don't control. And we use encryption on our backbone end to end. So any traffic that traverses that global network will be encrypted by default. There's no action required on the user. There's also reliable performance. By controlling the path that customers' traffic traverses, we can be very pointed with where we have that traffic flow and avoid internet conditions that would otherwise be very difficult, if not impossible, to control, just having traffic traverse the public internet. It also helps from an availability perspective. We can control scaling and redundancy at a global level, maybe operating out of multiple regions, and then connecting everything together through our backbone. So our customers can take advantage of this availability in addition to the performance and the security. And ultimately, it's about connecting closer to customers. The larger distances that you have and more latency, typically the worse performance you'll get out of your applications. By avoiding internet hotspots and suboptimal external connectivity, we can really improve the user experience and make applications perform better. And we can do this with both Global Accelerator and with CloudFront. If we take a look at the traditional internet path that a customer might take to an application, we'd obviously love it if everyone had direct fiber into one of our regions, but that's just not simply possible or scalable. So the next best thing is going over the internet. And that can be quite a tumultuous path. There's really no control over the path that traffic takes throughout the internet. Once it leaves the end user's router on the left and goes into a local ISP, it can take any number of paths throughout the internet. In fact, the return traffic could come back over a completely different path. So aside from being wildly unpredictable, it's hard to account for things like jitter and latency, which can vary quite a bit. And it can just take one of these spots, like say point D here, where there's a little bit of a delay or packet loss, and that could really make the entire application perform poorly. So each of these hops impact performance. It's another hop, there's a routing delay, a processing delay, and then moving the traffic along. Further, you can get out of order packets and packets coming not in the right sequence. So that can really introduce risk to the application, both the performance and the availability as it traverses the internet. this is really why we have our global network with edge locations. We want to get user traffic onto the AWS backbone as quickly as possible so we can control it and have predictable and repeatable performance. Essentially, by using services like CloudFront and Global Accelerator, we use another service called Route 53, which does domain name to IP resolution. That helps us resolve the names, in the case of Global Accelerator, to the Anycast IP address, or CloudFront through a CNAME to the local distribution. We're able to go and resolve an IP address that's at our closest point of presence. So the traffic will enter the AWS global network at one of our edge locations and then leverage our global network to get to the region. So essentially, we've removed all of the middle pieces here, and the user is essentially connecting directly to the AWS region through that local POP. So this results in greatly improved performance, and we'll get into what some of those numbers look like and ways that you can leverage these technologies. To start with, CloudFront is our global content distribution network. Some of the benefits: it's fast, massively scaled, and globally distributed with 216 points of presence around the world. That's more than any other cloud provider. It's highly programmable, so it integrates with our native AWS services and can make use of our edge protections like AWS Shield. So we're able to provide both scale, performance, and security at scale. And then there's deep integration with other AWS services. So you can connect in and integrate natively, have APIs calls just like you would with anything else in AWS, and get to the point where everything is deployed in CloudFormation, including your backend infrastructure and a CloudFront distribution to support it. We also, some key improvements. We have the ability to do origin failover. We've added support for ECDSA certificates. We can do request body access and S3 origin support for Lambda at the edge. So we've continued to improve and make the service better. And to that point, we have a number of very large customers using the service. Some examples here: Hulu, Prime Video, Slack, and Canon. The odds are pretty good. If you've browsed the internet today, you've probably hit the Amazon's CloudFront and served content from our content distribution network. There's so many companies and organizations that leverage CloudFront that you've probably done that today. If you've watched Thursday Night Football, that's something that we actually delivered last year through Prime Video to over 200 locations using CloudFront. So definitely a way to improve scale and availability. And case in point, we're using it internally to serve out some of our services as well. When we look at the CloudFront global network, similar diagram to the one we had before, we just removed the interconnected lines that were on the previous ones. We can see there's a few components. There's points of presence here. Some locations we have so many points of presence that we just depict that with a purple dot. So we can see that there's multiple points of presence. And then we have a regional edge cache, which is within a region provides a larger and deeper cache. And we'll get into what the flow and traffic looks like through there. You can see we have global coverage throughout our points of presence around the world. So pretty much most places you have a point within the country, at very least, if not closer, where you can get access to the AWS network and get improved performance for your application. If we look at how CloudFront shields your origin, so your users will connect into an edge location, and that edge location will have a subset of services running within that region. So we can provide services and accelerate traffic, and it provides caching capability. Then there's also a regional edge cache. This is a larger and deeper cache. So we can augment that capability of the edge cache. For example, if you have very large video files or files that users need to download, that could be more efficiently stored and served up through the regional edge cache. And then the very last part is the application origin. So this is for the backend server. And the goal here with CloudFront is to serve most requests and as much as we can from the edge location and from the regional edge cache. And that has the net effect of reducing the load of the backend infrastructure. If you're serving files through CloudFront, you don't need the capacity and EC2 instances and load balancing capability because you're serving that from the edge to the user, and overall actually reducing your infrastructure costs. If we look at the CloudFront architecture, the key piece is the DNS intelligent routing based on latency and availability. Using this, we're able to determine the best location to have a user's traffic enter our network, and we do that through the common DNS, the domain name system. We're able to do that resolution. From there, we respond with the best region for the user to connect into. So they'll connect into edge locations, and those edge locations also will then connect into regional edge cache and then into the origin. On that edge location, we're actually running a few different services. So we have our Route 53 DNS service. That's where we do our first tier of caching. We have Blackwatch DDoS protection. So we're able to, through AWS Shield, block some volumetric UDP traffic and typical types of DDoS mitigation that would be quite difficult to do without a service like this. And then we also have WAF, our web application firewall. So if you tie a WAF rule set with the distribution, we can perform that filtering right at the edge. Then our regional edge caches provide a parent mid-tier caching. They do TCP optimization, and they do origin connection persistence. So they handle the connection to that backend origin, which is the servers serving up your content. If we dig in a little to see what this looks like from a user perspective, let's say I have www.example.com. I would create a CNAME to my CloudFront distribution, which in this case, we're saying d12345.cloudfront.net. It'll always be a .cloudfront.net IP address or hostname. So if my user requests some file, let's say it's our index.html page, it goes into CloudFront. CloudFront actually doesn't have that piece of content. It's the first time it's been requested. It'll go back to the origin and download that content and store it in the cache, and then respond with that content. Now my next user comes in and performs a GET request for that same index.html page. Here, since we already have it in the cache, CloudFront can just respond directly back without reaching the backend server. So we've removed a whole number of steps. Just the pure number of requests is reduced. We don't need to talk to backend servers at all. And we serve this content directly from our cache at the edge location to our user. So it'll be less expensive, but also more performant. There's a few pieces to a CloudFront. So a distribution is kind of the first building block. So it's a unique CloudFront domain name to reference objects. So it's normally some letters and numbers .cloudfront.net. And here we're just saying abc123.cloudfront.net. And then within that origin, or within that distribution, you specify origins. You can have one or more origins. So in this example, origin.example.net, but it could be anything you want it to be. It could be the CNAME of a load balancer. It could be any number of other IP addresses. As long as it's public and on the internet, we can have it as an origin. And then we'll specify the type, which can be HTTP or HTTPS. A little bit of a call out here. If you want to use a custom domain name, we really recommend using a CNAME, and that allows us to resolve the IP addresses appropriately and make sure that your users get directed to the most performant location. Another key component is an origin. So after we've created a distribution, that's when we add origins. This can be any HTTP or HTTPS endpoint. It can use different TCP ports. You can specify timeouts, and you can also specify the TLS configuration. So essentially anything with a public IP can be an origin here. So we natively integrate with S3, so you can have an S3 bucket as an origin. You could use EC2 instances with elastic IP addresses as origins. It could be an elastic load balancer with public IPs. And again, all those are native AWS services, so we can natively integrate and have that tight integration with the AWS ecosystem. For other services, though, we can create custom origins. And this could be a web server on-prem. It could be a web server somewhere else on the internet. As long as it has a public IP address, we can route traffic to it and still use the AWS global footprint and our global network to accelerate your end user application. In terms of selecting an origin, we can actually have multiple origins under a distribution and control our traffic flow. In this example, let's say we're hosting a website. If my user goes to the website and types in index.php, we can see here that we'll take the path to our origin B there, because that's where we have a rule for a wildcard rule for star.php. Now, if in loading this web page that PHP directs some images to download, we can download that from origin A, which is where our JPEG images are stored. And this can be an S3 bucket. It doesn't need to be a backend web server at all. Same thing with our CSS. We might want to store that in another origin, and that could be another S3 bucket where we store our CSS, our cascading style sheets that tell the website how it should look. And then we can have a catch-all default. And maybe this goes to a 404 page that is just something that we don't want a user to see, or they've requested something. So if I request like a header.gif, there's no rule for a GIF, so that would default to origin D, and we could have that be a 404 page. So we're able to build out complex flows through multiple origins, and this is all unbeknownst to the user. This is all on the AWS side, and can have different controls and mechanisms around deploying each of those elements. Another feature that CloudFront offers is Lambda at the edge. So Lambda is our function as a service offering. We can access and deploy arbitrary code as needed, and then power it off. It's completely serverless. What this allows us to do when integrated with CloudFront is modify our origin or our requests. So we can see here we have a viewer request. There can be an origin request. There's multiple points when the TCP flow is kind of intercepted at the application layer, and at each of those locations, be it from the viewer to the CloudFront distribution, or from the CloudFront distribution to the origin, or vice versa on the return path from the origin response and the viewer response, we can rewrite traffic at each of those. This could be a simple rewrite. It could just be to optimize or provide in some additional advanced functionality into your backend application. But it could also be used for things like website security, real-time image transformation, intelligent bot mitigation, and search engine optimizations. So at each of those places, we can rewrite traffic, and it might be something as simple as adding in a token or a header that we want to validate for a security reason to ensure that our end-to-end flow hasn't been modified, or that we're not being attacked, or something like that from a security perspective. So there's a lot of really interesting use cases there. Also, image size selection or stream selection. You might want to detect a user's backend throughput and then direct them to the right stream. You can do a lot of that type of advanced application intelligence that would otherwise be hard to do. We can integrate it right at the edge with very little performance impact. We'll now go in and talk to Global Accelerator, whereas CloudFront provides more of that object caching and making sure that we're storing objects right at the edge to perform end user performance. Here, Global Accelerator, we're more at the layer 4, at the transport layer, where we're optimizing and improving applications. Some of the key features of Global Accelerator is that it's a single entry point with global static anycast IP addresses. We actually get 2 IP addresses that are global when you launch a Global Accelerator. There's intelligent distribution and deterministic failover for UDP and TCP traffic. So we can fail and route traffic around our network transparent to the application when needed. We can target EC2 instances and elastic load balancers, currently AOB and NOB. It's also easy to set up and manage with fine-grained controls. The first time I personally set one up, it took a few minutes, and I was just pretty amazed by the fact that I deployed a global infrastructure with just a few clicks in the console. So it's really powerful from that perspective. And all the traffic flows through the AWS backbone and is protected from DDoS attacks. So if nothing else, adding into an existing application can give a global footprint very easily and protect against DDoS attacks. There's the core kind of technology behind Global Accelerator is Anycast, which, if you're familiar with BGP, is a feature that allows you to take an IP address and announce it out of multiple locations. The definition here is a network addressing and routing methodology in which a single destination address has multiple routing paths to N+ endpoint destinations. Really a complicated way of saying we have an IP address that we can advertise around the world and then draw traffic into our network and route it intelligently from there. So this actually helps us a lot. So we only need to whitelist 2 IP addresses. I've talked to a number of customers where their use case was simply just having 1 or 2 static global IP addresses for their services around the world. And that's where the solution shines. Aside from needing any acceleration, we can provide those 2 static IP addresses that can be whitelisted and used to give to your customers around the world. It also reduces global address complexity. I've seen some very complicated IP schemes and ways to route traffic globally around networks that are cumbersome, hard to set up, and actually quite error prone. So we can reduce all of that by providing that service with Global Accelerator. We can also do source obfuscation. So if you want endpoints that are truly private and can't be reached at all, we can support that with Global Accelerator. We can have private EC2 instances and private application load balancers. This is actually pretty powerful as well. We can have completely private infrastructure without public IPs. So Global Accelerator is our true entry point into the application, and there's no way to get in without that because it's all private IP addressing for the backend infrastructure. It also gives us a global presence. As soon as you launch Global Accelerator, regardless of where you launch your infrastructure, you have a global presence with the BGP Anycast because we're announcing those IP addresses globally. Some use cases, both non-HTTP and HTTP traffic. On the non-HTTP side, your typical gaming UDP type applications, real-time video, VoIP, voice over IP, VPN, we can natively integrate. There's a checkbox when you launch a site-to-site VPN, so we can accelerate that actually. We built that into that service. There's DNS hosting for UDP, IoT, file uploads, push notifications, those type of typical applications. Also on the HTTP side, so blue-green deployments, A/B testing, static IPs for IP whitelisting. I think that's a big one. I've seen a lot of customers want to do that. And then also failover resiliency for multiple region applications, especially if you have more interactive and applications with dynamic content. Global Accelerator can really help there. Whereas if your application is more static content, it can benefit from caching. Something like CloudFront might be a better option there. We can see at the bottom here, we have a number of customers that are using this service, and it's really helped them build their application out globally and really take advantage of having multiple regions and having the AWS global backbone. I know I've worked with one real-time streaming customer who was having some issues in one of the regions, and it simply turned out just putting Global Accelerator into the path instead of directly accessing the region improved performance quite significantly, and they were able to get that up and running pretty quickly. Now I'm going to dig into a little bit of the routing and endpoint selection that we have with Global Accelerator. So when a traffic comes into Global Accelerator, we'll look at the 5-tuple, and one of the first things we'll do is we'll pick the optimal region. So we can tell based on where traffic comes in, and we know the time it takes to get traffic around our network and what our network looks like at any given day. We can intelligently pick the optimal region. So be it lowest on latency, we can do that and then select the region. From there, we'll take a look at that 5-tuple hash, and that determines where within the region we'll route traffic. So in this example, the user happens to be closest to our US West 1 region. That's the optimal path. So we're going to that region. And then we're looking at the 5-tuple, and we happen to have 2 endpoints. So we're balancing traffic between those 2 endpoints based on that 5-tuple. So ongoing communication will be kind of sticky to that same load balancer, because as long as we keep the same source and destination port. However, if we were to open up another connection, as we can see, it would be routed to a different application load balancer if any of those 5-tuple parts change. We also have the ability to do regional traffic dials. You can make them as low as 0 for no traffic or as much as 100 for 100% traffic. The default is going to be 100%. So in this example, we have 100% traffic flow sent to US East 1 and US West 1, and traffic is evenly distributed between those 2 regions. and that works right out of box. We also have failover for a region though, regardless of, even though we have this 100% rule, if there's no healthy targets within US East 1, then we can have all of that traffic go to US West 1 and we don't experience an outage, which is actually pretty powerful to have that global scale load balancing and failover. Now, let's say we wanted to have a region, maybe it's a standby region, or we're doing a test deployment where we don't want any traffic to route to, and actually create a rule and say 0% of my traffic can flow to US East 1 and 100% can flow to US West 1. So we can still have a multi-regional infrastructure and then fine-grain and control where our traffic is going to. And again, like a dev test or testing failover, there's a lot of options here. This might be part of your DR plan to have no traffic flow to one region and see how the application fails over. Aside from influencing traffic to the region, we have control over traffic within the region through endpoint weights. So our default weight is, our max weight is 255, the default is 128, and we can tweak those numbers from there to control our traffic flow. So we can see in US East 1, we have the default of 128, so traffic will be evenly split between the two ELBs. In US West, we want more traffic to go to the bottom load balancer, so we have 64, 192 as the split here. And we'll see traffic can then route, and we'll get the expected flow here. It might be that we're doing a new deployment, we want to control the amount of traffic going to a specific load balancer. Like in US West 1, we might be doing a test deployment here. We only want to funnel some of the traffic to the new load balancer. There's a lot of functionality and customization that can be done there with your traffic flows. Another option we have is client affinity. For applications that are more interactive and require back and forth connection with a stateful connection with the end user, this is a great option. So we'll still pick the optimal region for the application flow. And then from there, we'll look at the 2-tuple hash, not the 5-tuple hash. So we're essentially ignoring the source and destination ports. So as long as the same source and destination IP is used, we'll redirect that traffic all to the same endpoint. So good for stateful applications and things like that. You do want to watch, though, when you enable this, if you have a large organization that has hundreds or thousands of users that are coming in over a single IP address, you could create a hotspot in your load balancer. So you just want to make sure you understand your traffic flow. But definitely a good way for making sure that you have that persistence between connections when needed. If we take this a step further, we can have a truly multi-regional application. And in this case, we've got a transit gateway with multiple VPCs and an on-premise environment and a fairly complicated application flow. We can still front that with AWS Global Accelerator through our edge locations. So our users coming in will actually both be connecting into our service on the same public IP address. But you can see they're in very different very different geographic locations. So my users that are closest to the East Coast will be directed to US East 1, and my users in Europe and Asia will be directed to AP East 1. So we have this multi-regional, highly available, redundant architecture, and we can fail over between regions as needed. If one were to become unhealthy or if our service had issues, we could fail over to the healthy region. Well, let's take a look at what the performance looks like. So if I was deploying in one region here in US East 1, all of my users around the world would have to connect into that one location. And again, this is over internet, so it's not really a reliable path, and performance can vary. So if we took this application, kept the same IP address, in this case for the backend source, we could put Global Accelerator in front of this. And we can see even within the US, we've improved performance by 3%. To some areas, we can go up to 10%, even up to 18% for some of our customers in the APAC type area. So just by introducing Global Accelerator, you can see here we can really improve the application performance. Plus, we can also have failover. So let's say we deployed a second into a second region in EU West 1, we can have 2 regions that are part of our Global Accelerator, and we'll direct users to US East 1 where it makes sense. And also some of those users in APAC will now go to EU West 1 through Global Accelerator. And now they're getting 25% performance improvement opposed to the 18 they were getting going to US East 1. So we're able to regionalize and improve performance where needed, and you can always add and remove regions and really influence your traffic flow. Now, if we were to have a problem with our application in EU West 1, we could actually just simply fail over. So now we'd go back and we'd take the path we were taking before. While we're still providing performance improvement, we've now failed over and we're still accelerating, which is actually kind of unique to be in a disaster recovery or disaster response scenario where you're actually still accelerating traffic. So I think it's pretty unique having the best of both worlds, of performance improvement and global availability. Hopefully that gave a good overview of both CloudFront and Global Accelerator. Go over some getting started guides. So we do have great documentation out there. You can go and follow those guides. I would say with both products, you can easily integrate into your existing environment seamlessly. You can create a CloudFront distribution for your production application without affecting the actual production flow, and then start funneling some of your traffic to the new endpoint that uses either Global Accelerator or CloudFront. With each, it only takes minutes to get set up and started and just to have your traffic globally accelerated. And you don't just need to take our word for it. We have a calculator out there for Global Accelerator. It's that third link I provided there. So we have a global speed test. You can launch and pick a region, and we'll show you, based on where your endpoint is, how much we can improve your performance with Global Accelerator. So it's great news, easy to get started, and you can go and actually validate that. We did want to end on pointing out that we do have free digital courses. So if you are interested in either Global Accelerator, CloudFront, or other AWS services like Transit Gateway and network scaling, we have free content out there. And then you also have the ability to validate that expertise with the AWS Certified Advanced Networking Specialty Exam. Just kind of get that token out there so everyone knows that you are certified and knowledgeable in that area. With that, I'd like to thank everyone for taking the time to watch this presentation. Hopefully it's been helpful, and thank you for tuning in.